Hello and welcome back to Mr. Gregorius Math. I was asked to make a little video about transformations of quadratics. So here I have the parent quadratic, y equals x squared. It has these key points, 0, 0, 1, 1, and 2, 4. These are, of course, the first square, the second perfect square, and the third perfect square, or the perfect square of 0, the perfect square of 1, and the perfect square of 2. And then, of course, symmetry on the other side to get to -1, +1, and -2, +4. Now, when we're talking about transformations, we're usually talking about graphing things in vertex form. So here I've got an example of a quadratic in vertex form. Y equals ax minus h squared plus k. Now, we can play around with these values of a, h, and k. For example, if I was graphing the quadratic y equals 2x squared, here I would have an a value of 2, an h value of 0 since there's nothing subtracted from the square, and a k value of 0. Now what that causes is it causes a vertical stretch or dilation. And I've done a little bit of arts and crafts here, so that way I can show some movie magic. Our regular parent quadratic gets stretched up by a factor of 2. So the distance from the horizontal axis to the parent is doubled to get to where the child is. And that happens symmetrically on both sides. So that's for y equals 2x squared. That's where a value is positive. If our a value is a fraction, like y equals 1/2 x squared, this causes, again, a vertical change. But this vertical change is a compression. So what we'll see is, we'll see our parent, that point at 1, 1 is compressed down to 1 and 1/2. And that point at -1, 1 is compressed down to -1 and 1/2. And so that is for when our a value is less than 1. Now, if our a values are negative, it just causes this whole thing to flip. So those are our a values. Next, we'll consider our h and k values. So suppose I had something like x minus 1 squared plus 1. Well, what that would cause is it would cause my parent quadratic, which I've got a poor analog of right here, it would cause my parent quadratic to move. Any moves inside the brackets are moves opposite to what we expect, and they're horizontal. So this -1 you might think goes left, it actually goes right. So it'll go right 1 unit. And this +1 right here is exactly the way we expect, so it would move up. And so y equals x minus 1 plus 1 would be our same shape parent, just moved 1 unit right and 1 unit up. So every point goes 1 unit right and 1 unit up, 1 unit right and 1 unit up. We do another one. I can do y equals x plus 2 squared minus 2. So this one is going to go 2 units to the left, 1, 2, and 2 units down, all the way down to there. Now, I know based off of the curvature of the camera, this seems like it goes through there. It doesn't. I'm twisting, and my arts and crafts aren't fantastic. But this point should actually be right here. And that point should be there. I just didn't do a very good job with my scissors. But the key idea is just watch the vertex. It moves over 2 to the right because this becomes opposite of what we expect, and 2 units down. Now we can also consider negatives. So y equals -x squared would actually look a whole lot like our parent function, except for it would be flipped over, because this negative implies a flip vertically. So this point gets flipped across the x-axis, this point gets flipped across the x-axis, and same for these and these. So that's the basics of transformations of quadratics. H and K are your slides or translations, and A is your dilation or reflection. Don't forget to join us next time on Mr. Gregorius Math when we take a look at solving quadratics in vertex form after you completed the square to get there. Also known as solving directly. Please hit like, subscribe, ring that notification bell. I'd like this to be positively ratioed so that way we can see that there's a positive effect of transformations on quadratics. Take care.